All right, guys, we're going to get started on the lesson today. Today we are starting Chapter 9. And Chapter 9 is going to be going over right triangles and trigonometric functions, so sine, cosine, and tangent. But today, we're mainly going to be focused on right triangles and the Pythagorean Theorem. So the Pythagorean Theorem is in a right triangle. So if we have a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the other two legs. Or as y'all probably more know it as a squared plus
b squared equals c squared.
Is going to be the Pythagorean Theorem. And this works if we have a right triangle. Now, interestingly enough, if the values of a, b, and c are all positive integers, so they are positive whole numbers, they don't have decimals or fractions, we call them a Pythagorean triple. So Pythagorean triple is any three whole numbers, positive integers, that satisfy a squared plus b squared equals c squared. It can be plugged into there and work. Now, these four here are common Pythagorean triples. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25 are all Pythagorean triples. There are three sets of numbers that work in the Pythagorean theorem. Now, we can actually have more different versions of each one of these here. Because we could also say 6, 8, 10, 9, 12, and 15 also work. And really all that we had to do to get from 3, 4, 5 to any of these here is, well, we multiplied it all by 2. Here we multiplied them all by 3. Because we're just taking 3, 4, 5 and multiplying them by some number. And we get the same thing, and it still works. For any of these here, we could actually multiply them by a common number, so 2, 3, 4, we can continue on, and they would actually generate more Pythagorean triples. The ACT likes using Pythagorean triples, especially 3, 4, 5, or any of its iterations on the test, or using any of the others here. So any of these here are Pythagorean triples. You don't have to fill these all in, because these are also listed in your book. So what we're going to start off with is finding the missing side length of a triangle and determining whether or not it's a Pythagorean triple. So when we look at this here, we have side lengths 5 and 12, and we want to find the length of x. And when we look at this here, we're going to be using the Pythagorean theorem. A squared plus b squared is equal to c squared. And c is always going to be the hypotenuse. And the hypotenuse is the longest side length in the triangle. So looking at this triangle here, which side length would be the hypotenuse? Which side is the hypotenuse? X. The hypotenuse is always going to be across from the right angle. The hypotenuse is always the side opposite the right angle. So here the hypotenuse is x, and so our c is going to be x. So we'll have x squared, which means 5 and 12 are going to be the values for a and b. So we'd have 5 squared plus 12 squared. Now at this point here, we need to solve for the value of x. We need to solve for that missing length. So the first thing we can do is actually simplify 5 squared and 12 squared. Well, 5 squared, 5 times 5 is, plus 12 squared is 144, is equal to x squared. Now at this point here, we can add 25 and 144, and if we add those together, we get 169. And last but not least, what do we need to do to get x by itself? We would square root we need to take the square root of both sides, because the square root of x squared is x. Because when we take the square root, we're trying to figure out what times itself will give us what's inside the radical inside this square root. So here we're trying to figure out what times itself would be x squared, which would be x. Yes. And for 169, we're trying to figure out what number times itself would be 169. And that would be 13. And we could type that into the calculator, the square root of 169, which tells us that this missing side length is 13. Now, would these here be a Pythagorean triple? Yes. Because 5, 12, and 13 are all positive integers. We don't have any decimals or fractions. So these here would be a Pythagorean triple. So yes. Any other questions on this here? Are you ready for the next one?
Yeah.
So looking at this one here, we are going to be using the Pythagorean theorem, a squared plus b squared equals c squared. Since we do have a right triangle, we can use it to find the missing side length. Now we do need to know which one is going to be the hypotenuse. X, because again, it is opposite the right angle. So our c is going to be the x squared again, which means 5 and 4 are the values of A and B. So looking at this here, are the values that we know, the side lengths that were given, not as a variable, but as numbers, are they on the same side of the equal sign? Well, yeah, we have 5 squared plus 4 squared, yes? Can I type that all into the calculator? Yeah. So we don't have to do it one step at a time. We could actually type in 4 squared plus 5 squared, and the calculator will actually solve that for us.
That's all we have to do is put 4 squared, 5 squared?
Almost. Well, 4 squared plus 5 squared is going to be 16 plus 25, which is 41. So it tells us that x squared, whatever that side length, the hypotenuse squared is, then we would square root both sides. And the calculator tells us that x is, I think it told you square root of 41. Because the square root of 41 does not have a perfect square. It doesn't have a number, a whole number that times itself will give us 41. Now, if you hit the button right above enter as the approximation, it'll tell us that it's approximately 6 point. Did it give you a decimal? Hit the button above enter at the very bottom. Let's see. Because the two arrows will actually give us the approximation. That. 403. So the what button was it? The button enter. Yep, that approximates. Yeah. You're good. So this here, this guys, so this decimal answer that we get is a non-repeating, non-terminating decimal. It's an irrational number. So can we say that these side lengths are Pythagorean triple? No. Because we don't have integers. We have side lengths that are decimal. Mm-hmm. It's not going to be a Pythagorean triple. All right, guys. Any other questions on this one here?
No, sir.
All right. Let's look at this one here. So again, we're going to be using the Pythagorean theorem. A squared plus b squared is equal to c squared. Now it is helpful to find the hypotenuse first, so that we know what the value of c is. It is 14, because the side opposite the right angle this time is 14.
Which would be C,
Mm-hmm.
and then where would the 7 go?
So the two side lengths, the sum of the square of the two side lengths, so 7 and x, we square them both and add them together, is equal to the hypotenuse squared. Nope. Yes, sir.
I was trying to fish for a Swedish fish.
Let's focus up here. Now, looking at this one here, well, 7 squared and x squared are both on the same side, yes? So the two numbers that we got, 7 and 14, are on opposite sides. So unlike the last one where we're able to type the two numbers in and hit enter and we got the one side solved, here we can't do that because the two numbers are on
Opposite side.
But we can square each one individually. 7 squared is
14. Oh, no. Yeah. I haven't done squared in a while.
and 14 squared, 14 times 14 is. Now what do we need to do next? We need to subtract 49 from both sides.
There's a 147.
Yes.
Square root of 147 would be 7 square root 3.
Yes. Or 12 point what? And it keeps going on, yes?
Yeah.
So can we say that this here, these three numbers, these three side lengths, are Pythagorean triple?
Okay, now question. Whatever a decimal just keeps going on and on and on and on and on and on and on. We just put the first square root.
Yes, or we can put it as 7 square root of 3, because the answer here would be 7 square root of 3. Now, it does work out, since it is 12.12 going on, well, is that side length smaller than the hypotenuse? Well, yes. This side length has to be smaller than 14, because the hypotenuse is always the longest side in any right triangle. So whatever side length we found here had to be smaller than 14. Any other questions on this here? Let's look at one more like this, and then we will move on.
25
The hypotenuse
is C. And 15 would be A.
a squared plus b squared is equal to,
6 squared.
so we're saying that a would be 15
Yeah.
squared plus
Squared
is equal to
25 squared. So
15 squared is
15. Yep. And then 25 squared is 625.
and then we would subtract 225 from 625, subtract it from both sides, because these would cancel, telling me that x squared is
400. And 400.
So is this a Pythagorean triple? Yes. Realistically, if we took the square root of 400, we would have to include a plus or minus, because negative 20 times negative 20 is positive 400, because a negative times a negative is a... So whenever, realistically, if we take the square root of both sides, we take the positive and negative case. But here, we're trying to find the length of a line. The length of a line or distance can never be negative, so we don't talk about the negative case. So for these here, it's just 20. Okay. Any other questions on this here, finding the missing side length? We good? All right. We'll move on to the next part, the converse of the Pythagorean theorem.
Hey, your wife told me to ask you this yesterday. What was the joke of the day?
The joke of the day? Converse of the Pythagorean theorem. So, guys, the Pythagorean theorem works if it is a right triangle. So if we have a right triangle, then a squared plus b squared equals c squared. The converse is also true. If we could plug in the three side lengths so that a squared plus b squared is equal to c squared, then it is a right triangle. So the Pythagorean theorem only works if it is a right triangle. So if we were given this triangle here, and we plugged in the three side lengths into a squared plus b squared equals c squared, and it does come out to a true statement, then it has to be a right triangle. So we do know two side lengths are 7 and 8, yes? But seeing how that relates to the square root of 113 can be a little difficult. So let's actually approximate the square root of 113. So we can type that in. We can type the square root of 113 into the calculator. Most likely the yellow calculators will just throw back the square root of 113. 10.63. Well, we can say for certain that the square root of 113 is the hypotenuse because it is the biggest length. Now, yeah, we skipped a few. Now, for this here, I wouldn't want to plug in 10.63 going on because we don't have the whole decimal. But what we can take C as is the square root of 113. Now, the values of A and B are going to be 8 and 7. Now, on the one side, 8 squared plus 7 squared, those are all numbers. We can type that straight in. I can type in 8 squared plus 7 squared and hit enter, and we'll get 113. We can also calculate the value of C. So we can take the square root of 113 squared, and it gives us 113. Because here the square root and square actually cancel each other out. So, are these two sides equal? Are they the same? So, it's a right triangle. Any questions on this here? Are you ready for the next one? So we have this figure here. And we're going to use the Pythagorean theorem to determine whether or not it is a right triangle. So using a squared plus b squared equals c squared. Because yep, because it does come back again. 4 squared to 95 is going to be the biggest side length. because it's going to be about, I think it's somewhere, so 9, or because it's going to be almost 9.5 times 4. Well, 9 times 4 is 36, so it's actually going to be greater than 36. So our value of C is 9 square root of 95 squared. And A and B in this case is going to be 15 and 36. Sweet. Now at this point here, we do need to figure out what 15 squared plus 36 squared is. 1,521. Now we do need to plug in. This should be a 4. I think I wrote the wrong number up there, because it should be 4 square root of 95. Yep, because we can type that in as well. And I believe it should be 1,520. So do these two give us the same value? No. So it's not a right triangle. Because if they're not equal, then it's not going to be a right triangle. Any other questions on this here? All right. I think y'all feel pretty comfortable with that there, yes? As we type in A, B, and C and see if they are equal. If they're not, then it's not a right triangle. Now the last thing we have is the Pythagorean inequality. Now there are two inequalities that we can have. Now if a squared plus b squared is greater than c squared, then it is acute. Now if a squared plus b squared is less than c squared, then it is obtuse. So if a squared plus b squared is greater than c squared, it is acute. And if a squared plus b squared is less than c squared, it is obtuse. We don't know, we won't be able to calculate exactly what the angle is, but we can determine whether or not the triangle is acute or obtuse. So if we look at this here, verify that the segments with lengths 4.3, 5.2, and 6.1 feet form a triangle, and then determine if the triangle is acute, right, or obtuse. Now the way that we determine if it's a triangle is, well, if we take the two smaller lengths and add them together, and they're bigger than the third side length, then it is a triangle. Well here, 4.3 plus 5.2 is going to be 9.5. I think that would be if we square them. I think you multiplied. Because if we add them together, we get 9.5. 4.5 plus 5. Yes, we'll do that here in a second. Because really this part here is just making sure it is a triangle. Because if these two add together and be greater than 6.1, then it does work. So this is a triangle, and all the ones that, especially on the homework, will be triangles. They will all work out. But if we want to determine if it's acute, right, or obtuse, we're going to be taking a squared plus b squared and seeing how does it relate to c squared. Now, 4.3 squared plus 5.2 squared. If we calculate it, we get 45.53. So the two smaller side lengths, when we square them and add them together, we get 45.53. Now the hypotenuse, the bigger side length, is going to be our 6.1. And if we square it, we get 37.21. Well, which one is bigger? The 45.53. So that means that a squared plus b squared is greater than c squared, so it has to be. Because if a squared plus b squared is greater than c squared, then it is acute. So yes, this is a triangle, and it is acute. Any questions on this here? Verify that the segments 3, 4, and 6 form a triangle. Well, yes, because the two smaller side lengths, 3 and 4, if we add them together, we get, and 7 is greater than 6. So this does make a triangle. Now to determine if it's right, acute, or obtuse, we need to see how a squared plus b squared relates to c squared. Now our a and b is going to be 3 squared plus 4 squared. And if we type this in, 3 squared plus 4 squared, we get 25. Now the value of c is 6. And 6 squared would be? No, that's fine. 36. Well, which one's bigger, 25 or 36? So that's telling us that c squared is bigger than a squared plus b squared, so it has to be an obtuse triangle. Any questions on this so far? Let's look at one last one. And that is this one here, 2.1 and 2.8 and 3.5 are the side lengths. Well, 2.1 and 2.8, if added together, would give us 4.9, which is greater than 3.5. So this would be a triangle. Now we need to relate a squared plus b squared and see how it relates actually to c squared. So a is going to be 2.1 squared plus 2.8 squared. If we type these in, we get what? You have it? 12.25. Now the value of c here is 3.5. And if we take 3.5 squared, we get 12.25. So which one's bigger? Well, they're equal, yes. So this is right. Because if they're equal, then it is a right triangle. If c squared's bigger, it's obtuse. If c squared's smaller, it is acute. Any other questions on any of this here? And that's it.